Our final page is multiplying, so you can see they're multiplying. And before we start, you might want to divide it up into 4 separate. We're going to do 4 different things here. So let's start up here in the top left corner. And what I'm going to do here, I want a different color. Oh, I haven't used this weird green. So monomial times a polynomial. So an example looks like this: 3x times 2x squared plus 4x plus 9. Oh, 4xy. Let's make that 4xy plus 9. So when we're doing this, we're really just distributing. So if you want, you can put distribute. Now you are changing exponents now. So I don't know if you want to put up here, change exponents. Yes. To remind yourself, if you're multiplying, you need to change your exponents. You need to add them. Okay, so let's look at this one. I'm going to put a 1 on my invisible 1, make it visible. I'm going to put that on all of them that I need them. Okay, I'm going to distribute. Now, when we do that, we multiply the front numbers together, so that's 6. And these are like bases, so we're going to add exponents, x to the 3rd. I'm going to go to the next one. I multiply 3 times 4, and that's a 12. X to the 1st times x to the 1st, add exponent, that's x squared. And this y doesn't have anything to multiply, so it just gets attached. And the last one, don't forget to go all the way. 3 times 9 is 27. And then this x to the 1 is just hanging out. You can put a 1 on there if you want, or you can finish it. And so, oops. There's your answer. That's a terrible circle. All right, let's do a polynomial times a polynomial. Okay, can you see that, I hope? All right, in this one, I am going to use the box method. You can use the FOIL method, but I'm going to do box. So FOIL or box. Again, that means we have to change the exponents. We need to add our exponents. So let's give you the problem. That would be helpful. 2x minus 4 times 3x plus 2. Now, this is where I see people get confused because they think it's time to stack and add. It's not. Look between there. There's no addition, so there's no stacking and adding, okay? This is completely different. There's an invisible dot in between there. We're multiplying. So this is a 2 by 2, so I'm going to make a 2 by 2 box, okay? I'm going to put 2x minus 4 here, 3x plus 2 here. So remember, we have invisible ones on these x's so that we remember what we're doing. When we bring them together, we multiply the two numbers, so that's 6. The base stays, we add the exponents. 2 times 2 is 4, and there's nothing to do, so I'm just going to keep that x right there. There's no x to multiply. Negative 4 times positive 3 is negative 12, and then there's just a plain old x. And negative 4 times 2 is negative 8. Now, usually before I write this answer down, I look to see what's the same. Well, there's nothing that goes with 6x squared, so I'm just going to write that down. But these two can go together because they both have x's on them. Negative 12x plus 4 is negative 8x. And then this negative 8 can go on the end. And that's my answer. Okay? Let's come to the bottom left and let's do a special product. People get this one wrong all the time, and I do not give partial credit because you either know how to do this or you don't. A special product looks like this: x minus 5 squared. Remember, that's the whole group written twice. So x minus 5 times x minus 5 is what you have to do here. Do your box, a 2 by 2. Wow, I made that really small. I hope I can fit. X minus 5. X minus 5. Let's make our invisible ones. If you want, you could even make them in front. There's ones there. Okay? 1 times 1 is 1. I can write that, I don't have to. X times x, add exponents. So that's x squared. 1 times -5 is -5, and then there's just an x. -5 times 1 is -5, and there's just an x from here coming down. And then -5 times -5 is positive 25. And so my final answer, let's go through. We have 1x squared, so I'm going to leave that there. With or without the 1 in front of it's up to you. These two can go together because they both have just a plain old x. Well, -5 and -5 is -10. Since we're adding, we don't change exponents. And then a plus 25. Okay? Now the last one's a tough one, but I want you to see this because it's going to show up on the test. Maybe it's a bonus. And you know you have to try them. Binomial times a trinomial. So it's 4x minus 2 times -2x squared minus 3x plus 6. If I have a binomial times a trinomial, I need a 2 by 3 box. Okay, so 4x minus 2 is my width, and my length, -2x squared minus 3x plus 6. And I'm just going to do each piece. Oh, let's make our invisible ones visible. Let's see, what do I need? One here and one here. Okay? 4 times 2 is -8. X to the first times x squared, we add exponents, so that's x to the third. Now it doesn't matter which one you do next, but I'm just going to keep going this way. 4 times 3 is -12. And I have x to the first times x to the first, so that's x squared. Add exponents. 4 times 6 is 24, and then x is coming along for the ride. -2 times -2 is +4, and the x squared just came along for the ride. -2 times -3 is +6, and if you want to put a plus in front of these, that might be helpful, in front of the positive one, and then the x comes along for the ride. -2 times +6 is -12. Now we're going to add. So we got to be careful here, and we got to look and see what we can add together. Well, let's look for any x to the thirds. Well, there's only one x to the third. It's this one. So I'm going to write that down first. -8x to the third. Now I'm going to look for my x squares. Well, these two are x squares. So 4 minus 12 is -8x squared. And then these two just have plain old x on them. And again, now we're adding, so we're not changing exponents. 6x and 24x. That's going to be 30x. And then our last one is -12. And so this is our answer to a binomial times a trinomial.